Hello everyone. In this video, we will learn how to integrate functions which are products of powers of cosine and powers of sine. But we will focus only where at least one of the powers is odd, either j or k, well, or both of them is or are odd. So you will see that when one of these powers, at least one of these powers is odd, integrating can be done by u substitution. So the key trick here will be substitution. How does this work? Let's go through some examples and see how this works. Here, the first example is integral of cosine x times sine to the power 4x dx. Well, the powers here is cosine power has 1, sine power is 4. So this is odd and we are in the right place. How we can use this odd power? Well, let me just write an equality here and rewrite this thing. What you should have in mind is that, so let me write it as note, that the derivative of sine x is cosine x. In other words, if I write in terms of the differential, this is cosine x dx. Well, cosine x dx is there, so that gives me a hint that I can use substitution. What's substitution? The substitution where I set u to be sine x. Then as a result, du will be cosine x dx. And I have du here. What about this piece? Well, this is sine to the power 4. U is sine, so this will be u to the power 4. So applying that substitution, my integral turns to a u integral, which, well, in this case, it's a very simple, just power rule, u to the power n. The integral is u to the power n plus 1 over n plus 1. Well, since we use substitution, the process is not complete unless we plug in back what was the original function for u. So sine, we set to be u. So I have, that is my substitution, the result of my integral. So here the key point is that the 1 power of sine or cosine, well, can be used to generate du when u is equal to sine x for the first one, or if you're taking the other one, you set u equal to cosine x. So that's the key point. And that's basically what you need to know. However, there are some steps that sometimes you need to add to this key point, and we will see it in the second example. Here, I have power 3 of sine, so odd power is for that. Even power, cosine can have also even power. It's odd power, but we'll just focus on this case. So what I do, I need the key point saying what is that I can separate 1 power from that odd power of sine or cosine. And I use this piece here to generate my du. Okay, so I know already that I will use u substitution. So u substitution, let me write here what will it make for us. So u, I want to set u such that its derivative is sine x. Well, cosine x, well, it's not quite true that the derivative of cosine x is not sine x, it's minus sine x. Yes, but that minus is not a big deal. So I can see that this piece is going to be minus du. And well, with that substitution, this will be u to the power 4. How about this piece here? This is not in terms of u. Well, there is a good thing there. Note, we can write sine square x in terms of cosine x, or in this case u, using, we have this, remember, very nice, sine squared x plus cosine squared x is equal to 1. So I can rearrange that and write that whenever you see sine square x there, you write it 1 minus cosine x square x. So that way, basically, I have this piece here, and it is 1 minus cosine squared. And if I write it in terms of u, it will be 1 minus u squared. So all pieces for me to transfer my integral to u integral is done. So I need to rewrite this thing now. Sine 3x dx equals to integral u to the power 4, 1 minus u squared, and du, I'll put that minus sign up there, down there. Okay, I turn my x integral into u integral. If I expand this, this is a simple integral. This is integral of just the polynomial. And well, linearity of the integral and power rules tells me that, well, this can be integrated easily by just this. Very nice. I'm not done. I have to put back in my original function in terms of cosine. So minus cosine to the power 5 x over 5 plus cosine to the power 7x over 5 plus c. That's the integral. So not only I need to know that substitution works, also, so the key point for this example was that, key point is that even powers of sine, well, and also cosine can be written in terms of cosine, well, cosine x. If it was cosine, then you can write it in terms of sine x. You can turn them to each other. But using the power, the identity that cosine squared x plus sine squared x equals 1. This is Pythagorean theorem basically written in the trigonometric language. Okay. Well, let's do one more example here. I have, well, you may say, where is the cosine? Didn't you say that product of powers of cosine and sine? Well, you're right. I can write this cosine to the power 0 x and sine to the power 5x dx. Well, that odd power, that power of cosine 0 is even. Well, and the power of sine is odd. So we are in the case that we can deal with the trick that we have. So I won't write that power. So first thing is that you separate 1 power of x to make sure that you can deal with the substitution. What would be the substitution? Well, actually, the substitution here is u is equal to whatever which gives us the du as sine x dx. Well, that's cosine x. Well, from there, du, well, I lied. I will have a negative sign there to just deal with that case. Okay. How about this piece here? Well, sine to the power 4x, I need to write it in terms of cosine. How do I do that? Well, I write this as sine squared x to the power 2, but sine squared is nothing but 1 minus cosine squared x squared. So this way everything can be written in terms of u. What is missing is we haven't changed the limits. So I have to, when you're doing substitution for the definite integrals, you not only change the u, you also change the limits. You not only change the integrand from x to u, but also the limits from x to u. So lower limit is x. So in terms of u, this is cosine of 0, which give me 1. So my lower limit turns to 0 to 1, and upper limit, which is pi over 2, turns to cosine pi over 2, which is just 0. So the upper limit will be 0. So let me complete my substitution here. Sine to the power 5x dx. Here I have lower limit turns to 1, upper limit turns to 0. And this guy here is 1 minus u squared to the power 2. So I have 1 minus u squared for sine to the power 4. And that part here, sine x dx, is minus du. So I will put minus outside and just do this. Well, this is u integral. And now, well, I can expand it. A minus b squared is a squared minus 2ab plus a squared, which is u squared is u to the power 4. Well, there was a minus sign out there. I will multiply that minus sign as well, just to have du 1 to 0. Now I have, well, simple linearity, and power rule will give me everything that I want. Minus u plus 2/3 of u squared, u cube, minus u to the power 5 over 5. Go from 1 to 0. This is fundamental theorem of calculus. Okay, let me write down here. When I plug in 0, everything will become 0. Yes, minus, when I plug in 1, this will be minus 1 plus 1 to the power 3 is just 1. So I have 2/3 minus 1/5. Okay, so then find the common denominator. Oh, by the way, okay, I have a minus sign out there. This will be minus 15 plus 10 minus 3. And that will give me minus 18 plus 10, which will be plus 8 over 15. So we found the integral powers of sine to the power 5x using the trick that we learned. Just before I finish, I will give you a summary of what we did here. So when you're integrating cosine to any power, sine to the odd power, there are few steps that you have to do. The key point is that we are going to use u and substitution. First is that you separate one power of sine, that is there. That one power we will use to generate du later. The even powers of a sine, we can write it in terms of cosine using this factor here. So as I showed you in some examples, you have sine squared as 1 minus cosine squared x. That's the second step. The third step is that, well, set u equal to cosine x, then du will be minus sine x. So by applying all these three steps, you have all the components to transfer your substitution. So transfer your x integral to u integral, you'll get a u integral. Well, similar or accordingly, we can do when we have integral of cosine to the power odd x, sine to the power any number you like. This time what you will do, what we said here, you will apply for the cosine first, so separate one power and then write the rest of the powers as in terms of sine. You transfer u substitution, and then you get a u integral and solve that one. Okay. What will happen if both of the powers are even? That's another video which will come after this video.